Okay, let's do a Shango style introduction. 1937 Torn.E.b radio made by Telefunken. Hello and welcome to Void Electronics. Today we have something really special on the bench, and that is this Telefunken Torn.E.b radio from World War II. So this was a field radio or some sort of portable radio, I guess, so you could wear this like a backpack. It had one more box like this one, which was the battery box, which made it into some sort of portable set, if you will. Now this came from a friend who took care of the mechanical side of things. He also painted the front panel and so on, and he basically challenged me to get this working once again. So we have to fix it and we have to make some sort of power supply for it, because we obviously don't have the batteries. So let's get started. Believe it or not, we have the power cable for this, which looks like this. It has a military connector like this on one end. It obviously plugs in here. And then at the other end we have some sort of terminals that went to the batteries. And the batteries would provide 90 volts for the anode and 2 volts for the heaters. This is probably the oldest radio that I've worked on, so I'm really excited to work on this. So let's take it apart and see what's inside. But before that we need to talk about safety. A radio like this one is really dangerous because it works with high voltages, so you shouldn't try this at home. And if you do so, you do it at your own risk. With this in mind, let's take it apart. So to take it apart you have to unscrew the red circle screws, which seems to be a challenge in itself, but I think this one is okay. Okay, this one's out. Next one. Okay, this one's out. Okay, so this being a military receiver, I think it's really easy to take it apart, because these things were designed to be fixed. So this is what I love about old electronics in general. And sure enough, it just pops out. It's built like a tank, literally. So as you can see, you already have access to the tubes. They just unplug like so. They have a really weird construction. So in the field you could swap some tubes in 2 minutes and get it going once again, which is really nice. So this one has 4 identical tubes. They are RV2P800 with obviously some military symbols on it that I should probably not show you on camera on YouTube, but it says right here that it's something related to Wehrmacht. Really interesting tubes and really interesting socket. It just so happens that I have the socket for this tube. It looks like this. It's hollow and it has some sort of metal shield, and the tube pops right in like so, which is really interesting. It's unlike any other socket that I've seen. And we also have some German words written on it and the date, the 24th of October 1941. If you know what it says right here, please let me know in the comments. Thanks. So the tune circuits are all inside this drum that rotates using this big knob. Just listen to this. They don't make them like that anymore, do they? So it has 8 bands, I think, and some of the bands should fall somewhere in the broadcast bands, so I think we should be able to pick up some stations. The tuning range on this thing is from 96 kHz all the way up to 7 MHz or so. So it should pick up AM stations. Before taking it apart any further, let me give you a quick tour of the front panel. So this is not a superhet radio. Instead, this is a direct amplification with regenerative control radio, which explains some of the controls that we have here. First of all, the big knob is the band selector. This is the tuning knob. This is the regenerative control. This is volume, on off. This is a tone filter. antenna tuning, voltmeter for both the batteries. This is the power connector. These are the output jacks for the headphones. This is ground and this is antenna. And that's about it. To get access to most of the electronics, we still have a few screws to remove, and this should free this top cover, so let's give it a try. Okay, we're almost there. Oh, I think we have one more screw, sorry. And we're in. Oh man, this is gonna be a long video. I have some bad feelings about all these caps. I guess some of these need to be replaced, we'll see about this. And the plan here is to get it working without changing too much if possible. So let's see if we can find a good compromise here. What I want to do is look for some obvious faults, like shorted capacitors or something like that. I want to check the heaters of all the tubes. And if we don't find any obvious faults, then I will improvise some sort of power supply for it and power it up to see what happens. Let's start with the tubes. The heater is between this pin and this pin. I'll just check the datasheet for this. This one's okay. Next. This one's okay. This one's okay. And this one is okay too, which is really nice. So at first, this style of construction looks really intimidating until you notice some details. Every single component inside is numbered. And not only did they number the components, but they numbered the nets as well. So look at these capacitors, for example. This is capacitor number 5. I bet you can identify this on the schematic using this number. And it has two connections, connection 0 or net 0 and net 4. So I bet net 0 is the chassis. Let's see. Of course it is. So we know right from the start that all these capacitors are grounded on one end. And then the other terminal is numbered as well. This one, for example, is net number 4. And we can see that net number 4 also appears on this tube, on this pin. So that means we have a connection from here to here, right? Of course we do so. See? This makes troubleshooting really easy. I love it. Off camera, I checked all the capacitors and none of them is shorted. Even though some of them are maybe leaky, they indicate some resistance. I'm not sure if it's from the circuit or if it's their internal resistance. I will leave them as they are for now because I also noticed another issue, and that is the voltmeter. Unfortunately, the voltmeter is not working. I decided to test it before doing anything else because it might be easier to gain access to it at this point because some of the connections were left disconnected by the owner. I will show you what I mean by that in just a second. So to test the voltmeter, I removed all the tubes and I applied 2 volts directly on its terminals, and it draws some current around 16 milliamps. I don't know where that current goes, if it goes into the meter or somewhere else, but it doesn't do anything. And I also tried applying 30 volts on the 120 volt terminal and it also does nothing. So let's see if we can fix it. To gain access to the meter, you can remove this left part of the chassis, and in order to remove it, you have to remove the electrical connections right here. These are just 2 terminal strips that are soldered together, and the owner left them like this so I can gain access to the meter. So this will be relatively easy. So you have to unsolder all these. You have to remove a few screws and you also have to remove this spider component or whatever you want to call it, which holds this rotating drum. So this has to come out, and then this should come out as well. Let's see. Oh, it looks like it has some ground connections. Okay. Okay, let's leave it like this for now. The next step is to remove these screws, and this should free this left module, so let's give it a try. Okay, let's see, does it come out? And we have one more here. Okay, so it's slowly coming out. Have to undo these. And it's out. Nice. I wonder what this is. I think it's the audio section or something, because it has some transformers. Okay, the voltmeter is out. It's not stuck, fortunately, but it's not working either, so that means it has some sort of electrical issue, I guess. So here's what the meter mechanism looks like. It has two inputs, one of them is for 120 volts and the other one is for 3 volts. And it has a common ground, of course. And I'm reading open circuit between both of these and ground, so there is something wrong inside, of course. And I think the mechanism is working. So to test it, I think we can apply a test current from a multimeter set on ohms range. That will apply a test current, and this way we can see if the meter is working or not. So let's give this a try. And I want to test not just the resistance, but also the voltage, the test voltage. So this is why we have two multimeters here connected in parallel. The fluke here measures resistance, and the keysight here measures voltage. And as you can see, we have a test voltage of around 5.5 volts with the probes open, of course. Let's give this a try. Oh, this is great. So the meter mechanism is working. As you can see, it reads 23 ohms at a test voltage of around 23 millivolts. And we have a nice deviation on the needle. I'm not sure if you can see this. Okay, so the mechanism works, but this also means that the mechanism doesn't measure any of these ranges directly. So it needs two resistors, I guess, one for the 3 volt range and another one for the 120 volt range. And I can only see one of them, which is strange. And I traced the wires, and this one is for the 3 volt range. So I'm not sure where the other one is. Maybe it's hidden somewhere in the base or something like that. So if the resistors are open, this would explain why the meter is not working. And by the way, it has a switch here that changes ranges from one to another. And I tested the switch, and the switch is okay. So this means that the resistors are almost certainly open. The only nasty thing about this is that the resistors are really hard to access. I cannot see one of them at all, and the other one is behind the dial here. So I'm really reluctant to remove it, but let's see. And I definitely found one issue. So if you look carefully right here, the resistor basically broke off. So the solder joint broke off, to be precise. This is the terminal of the resistor, and this one, the lower one, goes to the switch. And they were supposed to be soldered together, and they're not anymore. Let's see if this fixes the meter. Unfortunately, I tested it, and the 3 volt range still doesn't work, but we have a partial success here. Look, the 120 volt range works now. We are feeding in 30 volts, and we definitely have some deflection on the meter. So we are making progress here. Now the reason why the 3-volt range doesn't work is because the wire broke off from the terminal all the way to the selector switch, which is weird. And unfortunately I don't seem to be able to remove the Bakelite base here, so even though I remove the screws, the meter mechanism doesn't want to come out. So I need to find a solution to rewire the 3-volt range. And I think I figured it out. So from this side I managed to desolder the resistor, which allowed me to remove the base, at least partially. And the reason why it didn't work is because the wire broke off. At least it was broken when I removed it. So let's see if we can resolder the wire, because the one for the 3-volt range is really delicate. It's the thin one that I hope you can see in the video, I'm not sure. And the thicker one is the one for the 120-volt range, and they both get soldered directly onto the terminals right here. I think this is what the issue is. Let's see if we can make this delicate solder joint. And here's how I fixed it. Fortunately this thing is magnetic, so it's stuck to my pliers, and I managed to solder a thin piece of wire at the end of the resistor's terminal, just to make it a little bit longer. And I think this will allow me to solder it back to its terminal. And this should fix it. Let's give it a try. Unfortunately that failed miserably, so we need a plan B. The reason why it failed is because the resistor for the 3-volt range is burnt out. So we need to add a new resistor, and in order to do that I soldered a really long wire from the 3-volt terminal that goes out, and it should reach the back of the dial basically. With this wire we will be able to add a new series resistor for the 3-volt range, and hopefully that would bring both the ranges back. Okay, so we are feeding 90 volts in using a sketchy power supply. Let's give it a try with the dial on. Okay, the moment of truth. Let's switch it to 90 volts. Damn, it's bang on. Unbelievable. So yeah, with the 90 volt resistor soldered in, it works. Now we just have to fix the 3-volt range. Now for the 3-volt range I added a series resistor. It's a 1.5K 0603 SMD resistor. And let's see if this brings back the 3-volt range. We are feeding 2 volts in, so let's give it a try. 3, 2, 1, and it does. Unfortunately the reading is too high, but it definitely works, so we just need to tweak the resistor and that's about it. And after some trial and error I managed to calibrate the meter. The SMD resistor was 1.5K and the meter was about 10% off. It was reading about 10% higher. So I thought that a resistor that is about 10% higher would bring it back into precision. So what I did was I handcrafted a 1.6K resistor out of 3 resistors. This one is 1K and these two are 300K. And I measured them to be as close as possible to the nominal values, and as you can see the meter is now bang on. We are feeding it 2 volts and it reads 2 volts. So we just need to put the resistor in, trim the wires, and that's it. So this turned out to be a bigger challenge than I thought, and that's because the big resistors didn't fit. So I had to rebuild the resistor network using SMD resistors, and here it is, you can barely see it. And here we have two 3.3K resistors in parallel, and I also added an extra 69.8K resistor in parallel just to bring the value as close as possible to the desired 1.6K. Let's see if this one fits. Okay, so let's see what we did. 2 volts and almost bang on. This is good enough, it's all I can do for it. How about 90 volts? Yep, this one is bang on. So that's it, we fixed it, finally. The next step is to fix the wiring harness for the power section. And that's because the owner replaced the switch here. Actually, he installed the switch because it was missing completely when he got the radio. But he didn't finish the job, so as you can see all the wires are just hanging in the breeze. So we need to rewire the switch. And here's how this goes. So power comes in through this interconnect, and we have 2 lines of course, for the heater and for the anode. So the heater is the red one right here, and the anode voltage is the blue one right here. So these are the unswitched voltages, and they need to go directly to the switch. And then the outputs, the switched voltages, need to go to this board here, to 2 points, that we can easily identify based on the numbers. So the heater voltage before the switch is connection number 1, which should go to the bottom of the switch somewhere in there, and is this one, which should show up in here. So it does. As you can see, this is connection number 1, the red wire. And then the anode voltage before the switch is connection number 5, according to the schematic, which is this one. It should go to the bottom terminal of the switch as well. And the switch connections are 2 and 6, which are stamped on the switch, of course. Number 2 is the red wire, and it's supposed to go to this terminal of the inductor, which is also stamped here with number 2. And the switched anode voltage is connection number 6, which is this wire right here. So as you can see, for the anode voltage, the switch was bypassed. So we need to remove this bridge. This one goes to the switch, and this one goes to the other leg of the switch, because this is the switched anode voltage. So yeah, let's redo the wiring. And one more thing here, we also have the switched heater voltage on an extra wire that goes back to the power connector on the front panel. So we need to run an extra wire from here all the way to the power connector. First of all, let's make sure that the switch gets its heater voltage, and to do this we just need to bridge these two wires. Let's see if we can remove the isolation on this old wire. This is going to be a challenge in itself, because it's hard as a rock. Let's see if this one fits. Okay, please don't break the wire. Yeah, it worked. It's fine. And now I need to prep them for soldering. So I will apply some rosin, just like in the good old days. And some solder, of course. Let's see if this one takes some solder. It does, but you have to insist, of course. Okay, and now we have to prep the other wire as well. This one looks really tarnished, so let's see. So there is some extra garbage on the wire that we need to take out. Okay, it fell in, so we have to flip it. Okay. Now we are ready to prepare the wire for soldering. Okay, I would say this is good enough. So now I will isolate it with some heat shrink. So let's just cut one to size. Maybe something like this. Okay, and now we are ready to bridge these together. These are rock hard, so they don't really want to bend. Okay, I hope I won't break them. I would say this is good enough. And now I will use my heat gun to shrink the tube. This one is set to the lowest setting, which is 150 degrees. And we'll just give it some hot air for it to shrink. And that's it, the first connection is done. They probably didn't have hot air guns back in the 30s, but if they did, they would have used them, so I think this is fair. And now let's test the connections. We should have a connection from here to here. And now we don't. Let's turn it on. Now we do. So far so good. So now we need to make a connection to the board, to connection number 2 after the switch. So this short wire needs to go here to the inductor. This will be a challenge because once again we need to remove the insulation from this wire. And that's it. Now we should have heater voltage all the way to the board. Let's check it once again. That's perfect. And you also need to have the switched heater voltage right here because this one goes back into the power connector. And we do. I will do this later, of course. And now let's do the anode voltage connections. First of all, these wires don't need to be bridged. And now once again we need to make sure that we have anode voltage to the switch. So I have to bridge these two wires, this one to this one. And then we will run the switched anode voltage to the board. Let's prepare this one for soldering. This one is so tarnished that I think it would be a good idea to clean it with a file. Let's give this a try. This should remove some of the oxides and it will make soldering a bit easier. Okay, I think we've exposed some fresh metal here, so let's try again. See, much better. And that's it. Let's test this connection as well. So number 5 from here should connect here to number 6. And it does. And now we just need to prepare a wire from here that goes to the power connector. And now we're back to the main chassis here, and just when I thought I was done with the power connections, we have some more connections to restore. So this is the power connector from the back, of course, and if you notice here we have a missing connection to this pin, and this is supposed to be grounded. So for some reason the ground wire is missing here, so you have to restore it like so. And it should be okay now. And we have some more bad news here. Unfortunately, I think the volume pot is broken. So look at this. It's supposed to be 50K, however it reads 65K between the ends. Now let's check between one end and the wiper. So this one goes all the way down to 700 ohms, which is pretty high. I don't think that's right, but okay. The value slowly increases all the way up to 47K for some reason. So this is pretty strange. However, the really strange reading is when we check within the wiper and the other end of the pot. So look, now we have 65K. Now we have a higher value, 67 or so, 70 something. And now it goes down, but it only goes down to 32K. It should be 0 ohms right now. So I don't even know how it's possible to get such readings. I removed it from the circuit and we get exactly the same readings, so the circuit around it doesn't affect it, and I don't see how it could affect it in such a way anyway. So yeah, this is really strange. I think what I'll do is I will connect a trimmer to this, at least for testing purposes, and then we'll look for a replacement. So I'm really confused here because I checked with the owner and the owner has a spare chassis and he gets exactly the same readings on the same pot. So I don't know, is this some sort of strange pot and this is what it's supposed to read or what? Let's just fire it up as it is and see if it works or not. So I think I will continue with the checks and try to resurrect it basically. Okay, so since this is uncertain, let's continue with the voltmeter. I think we need to put it back, wire it up to the two voltages, and then we need to reinstall this module and give it a try. Okay, the voltmeter is in now, but after some close inspection, of course we have some more connections to redo. So it looks like the audio output was disconnected for some reason, so you have to restore this as well. So the bottom lugs here are supposed to be grounded, and these two are supposed to be in parallel, and they need to be connected to connection 51, I think, which is the output transformer. So it's right here. And now it's time to put this left module back and restore all these connections. And now with the connections restored, I think it's time to do some electrical checks to see what we've done so far. First of all, in the power connector, the top right pin should be ground. So let's check if it is. Let's check to the chassis first. And it is. And now let's check if the heaters are grounded too. Okay, so the heaters are grounded. So far so good. Let's check if the heater voltage goes to where it should go. The heater voltage is the top left pin. And I think it should go here. Now it's off, so we don't get anything. Let's turn it on. And we have heater voltage here. And here. And here. And here. This looks good to me. Let's move on to the negative anode voltage, or the ground of the anode voltage, or whatever you want to call it. So it has some resistance between its ground and the heater ground, which is 220 ohms. I think that's okay. It's there regardless of the position of the switch, as to be expected. Okay, so this is the negative for the anode voltage, and this should be the positive for the anode voltage, which is the bottom left pin. Now let's see if this one reaches the voltmeter first of all. And sure enough it does, through a 100 ohm resistor, so I think this is okay. And let's see if it reaches the anodes too. For example, it should reach this anode. This is the output, audio output tube, and it does. It should probably reach this anode, and it does, through a really large resistor, and this one, and it does, to 10K resistor, and this one is okay too. So this one is a bit strange. This tube right here has a huge voltage between its anode and the anode voltage, so I'm not sure if that's okay. This is tube 56, connection 24. Let's assume this is okay and continue with our tests, but this is to keep in mind because maybe there's something wrong with the circuit here. And also let's check the power connector for shorts. So first of all, let's measure between the heater plus and heater minus. And we have 95 ohms. If we turn it off, we have a really large resistance, 170 megs, so I think this is fine. And now let's measure on the anode side. So this is between the anode minus and anode plus, or B plus, or whatever you want to call it. And it looks like we have a capacitor that's charging up or something like that. It's showing 100k or so. If we turn it off, we get a really large resistance, 270 meg. Yep, this is probably okay. And now with the tubes out, I think it's time to power up the heater rail to see what's going on. So we are on 2 volts on this. So far so good, no current draw. Let's turn it on. 3, 2, 1. And we have a nice reading here on the voltmeter. It's right on 2 volts, so I'm happy with this. It's drawing around 16 milliamps, which is probably okay. And now I think it's safe to put the tubes in, just for a quick test to see if the current draw increases. Okay, 200 milliamps. This is probably fine. Next tube. $400 milliamps. $600. Okay, so I think the heaters are happy. And these cables are not ideal for this because I can see a voltage drop here. We can compensate that, but anyway, this is working. Now I will remove the tubes and do the same thing with the anode voltage. Okay, now let's power up the anode voltage too. So the setup here is a variable isolated transformer, a rectifier. The rectifier goes to this 25 watt light, and on this multimeter we are reading the voltage that gets to the radio. And also, since this is a tube set, it's not a good idea to power it up without load on the output transformer, and for this we have a 2K resistor connected somewhere in the back. So let's slowly crank up the voltage. Excuse me, but the transformer is out of frame for this test. Okay, 14 volts, 30 volts, 50, 60, 80, and finally 90 volts. Okay, the light is off, so I think we're looking good so far. I connected a fluke as well so we can measure the current, and we have around 5 milliamps of current. I'm not sure about this, it could be okay. And now I think it's time to put the tubes back in and slowly raise the voltage to see what happens. So right now we are at full heater voltage and basically no anode voltage, just in case. And if we have any sort of audio output, we should be able to hear it in this guitar amplifier. Okay, the volume is in the middle. Let's slowly crank up the voltage and have a look at the current here. Okay, 9 volts, 13 volts, 15, 20, 30 volts, 40, 50, 60, 80 volts, and we have around 7 milliamps, so yeah, doesn't look too good because it isn't I don't see much change in the current draw, so yeah, I don't know if it does anything. Let's see. We have some sort of hum here. Let's try to tune it. Let's try to change this as well. Choose the regeneration. Okay, it's not doing much. Okay, so we have some more troubleshooting to do because it looks pretty much dead. So this set is supposed to draw around 800 milliamps at 2 volts, and I think we are close enough, so the filaments are running, and it's also supposed to take around 12 milliamps at 90 volts. And the current consumption is much lower than that, is just around 7.7 milliamps, so something's not right. However, the first thing that I want to try is the audio section, because I think the audio section would be the top priority to fix. Once we get the audio section going, then we can easily troubleshoot the radio, because you can simply hear in the speaker what it's doing. So to do this, what I want to do is to feed a signal from a test generator into the first grid of the audio tube, which is this one. The audio tube is right here, and the tip of the tube is the first grid. So I'm coupled into this on the socket, of course, using a 22 nanofarad capacitor just in case, because I don't want the radio to fry my generator. And we are feeding in 1 volt peak to peak. Let's give it a try. Okay, we definitely have a very faint tone here, and I'm not sure if this is okay or not. So the audio amplifier is definitely working, right? I can remove the tube and the tone is gone. So it does something, but it's very faint. I'm not sure if this is right. So my setup could also be wrong. This is obviously not designed to drive a guitar amplifier. So let's give it a try with some high impedance headphones. These are 2.2 kilo ohms per channel, and I'm running them in series. So this gives me 4.4 kilo ohms. Let's see. Ooh, okay. So it's hard to film this, but this is really loud in the headphones, so the audio amplifier is definitely working. Let's move on. Now I think it's time to check the voltages around the tubes. And I'm doing this because, if you remember from the initial part of the video, I said that we have a really high resistance between the anode voltage, the anode input I should say, and one of the tubes around here. So I think one of them is not biased properly, and the low current consumption makes me think that as well. So let's see. According to the data sheet of the tube, this is the anode, and the next pin right here is the second grid. So let's see. Anode 73, that's perfect, and screen grid 70 volts. Okay, next one, anode 87, perfect, screen grid 53, that's perfect. Let's move on. Anode 0 volts. So see, this one is not biased properly. Screen grid 36 volts. Okay, so we definitely have an issue here, but let's move on with the test and test everything. Anode, this is obviously okay, 74. Screen grid 64. So we have an issue around here. Once again, we need to look at the schematic and see where the anode goes. I hope that none of the chokes are open, because that would be a tragedy. I removed the power, and now I think we can test the resistances around here. So this tube is the audio detector, and the anode is connection 24. The tube is, by the way, tube number 56. So the anode is right here, connection 24, and it should go right here. Let's see if we have continuity. Okay, yes we do. And 24 goes into an inductor, and then after the inductor is called 25, which is on this standoff. Okay, it reaches the standoff, and after the inductor, this needs to go to the tone switch, which is in the left side of the chassis, that module that we've removed earlier. So let's see. On the tone switch I can see connection 25, this is stamped right on the terminal. Let's see if we have continuity between this standoff and the tone switch. And we don't, we have 200 meg or so. So this is the issue. I think we can bridge these two together and give it a try once again. Okay, so let's take a crocodile clip, put it here and here on the tone switch, and give it a try once again, and then we will figure out why this connection is missing. So now we should have a connection from 25 here all the way to the tone switch. And we do. Let's test it once again. Okay, 3, 2, 1, fire. I'm not sure if it changed anything. Let's try to tune it a bit. Yes, it works. We have some distinctive radio noises. I love it. Let's check the regeneration. Full regeneration here. I definitely heard some radio whistles, so it's doing something. It's really faint. Let's touch the antenna. Ha! It's working! Okay. So this is pretty silent without an antenna, but yeah. I think it works now. Let's hope I don't get shocked here, so I wouldn't recommend doing this. It definitely works. Nice! And I finally figured out the issue. Remember this thing? Remember that it had a wire on it? Well, this is connection number 25, so this piece needs to be here in order for the radio to work. That's because this one connects to this standoff here and to another standoff somewhere to the left to connect the audio detector's plate right here. So yeah, you need this, or you need an alligator clip like this to make it work. So there's nothing wrong with the radio, this is just a fault that I've created when I disassembled it. Now let's see if it picks up a signal produced by the signal generator. So we are at 750 kilohertz here, which falls somewhere in the middle of the fourth band of this radio, and I've enabled AM modulation 1 kilohertz 100% depth, and the amplitude is 1 volt peak to peak. However, this is not connected directly to the antenna, this is coupled just through the isolation of this wire, so it doesn't really need to be connected. This will be more than enough if the radio works. So it's like this. I hope you can see it. As long as we don't short it out, it should work. Okay, so let's see if we can tune it in on the test signal. Ah, it works. It's doing strange noises because the regeneration is at 100%. It should never be this high. And it's perfect right now. It's also very sharp. Nice. Okay, we can reduce the gain, can reduce the regeneration. It's still distorted, but it's definitely working. I'm so happy. All the components are original, so I haven't done much. I've just restored the missing connections here for the power connector and the power switch. Isn't this amazing? I think it is. Now let's see if we can also pick up the local AM station. I have here a random piece of wire. This is an audio cable that I'm going to use as an antenna. It's around 3 meters long and is not connected to anything. Okay, so we have some radio noise. I love it. Let's try to pick up the local station then. It should be somewhere in this band. Oh, here it is. So it's very noisy and distorted, but it definitely works. It needs some more work, but I'm so happy that it's working. Since this video got really long, I think it's a good idea to wrap it up here. So let's see what we've done so far. We managed to restore the connections to the power connector, the connections to the power switch, the connections to the banana jacks for the audio output, and we also managed to fix the voltmeter. And here's where we got so far. We are definitely picking up some stations here, however the audio is really distorted, which means that there is a lot more work to do on this radio. The nice thing about this is that the radio is already working with all its original components. Anyway, if you like this video, please give it a thumbs up, and if you're interested in more content related to electronics and programming, please subscribe to this channel because there is more content like this on the way. That's it for now. Bye.